Welcome back to Statistics on Catalyst University. My name is Kevin Tokoph. Make sure to like this video and subscribe to the channel for future videos and notifications. In this video, I'm going to show you how to conduct a one-way analysis of variance, also called a one-way Anova, and most people just shorten it to Anova. First, we're going to go into a little bit of the theory behind this and how you know when you would use it, and then we'll actually go to an Excel file and I'll show you how to actually run an Anova. All right. So, the one-way Anova is usually used when you have a situation that's very similar to what we saw for the independent t-test. Remember, for an independent student's t-test, we ran those when we had two groups and we were measuring one variable on both of those groups. Okay? The Anova is very similar to that, except for the fact that you have to have more than two groups. Because if you have two groups, that's by definition you're using an independent t-test. So if you have 3 groups or 4 groups or up to, you can have as many as you want groups, but you're measuring that one variable across all of them, that's when you use the one-way analysis of variance. Okay? So the one-way Anova is basically the same thing as an independent t-test, except you have more than 2 groups. So rather than 2 groups, 1 variable, you have 3 groups or 4 groups or 5 groups, and you're measuring that one same variable for all of them. Okay? Now, the actual computation of this, what the computer has to do, is more complicated because when you have 2 groups, and that's it, you're just measuring the differences between those. When you have 3, the computer has to run individual t-tests and then it does some more stuff, and it's really complicated. But ultimately you get a p-value out of it, and that's what you look at. Now let's look at some technical definitions and then also some examples of when you would know to use an Anova. So we've already said you have to have one dependent continuous variable, okay? Just like in an independent t-test, but you're measuring that one dependent continuous variable across more than 2 levels or groups. Okay, so it has to be 3 or more basically. And I've bolded that dependent continuous variable in each of these 3 examples. So let's look at these. And these are actually identical to the examples I used in this independent t-test, except for the fact that I've now added 1 extra group. So you'll see the difference. Let's say I want to measure systolic blood pressure. That's my variable I'm measuring between 3 groups: an antihypertensive drug group, a vasodilator group, and a placebo group. I've got 3 different groups. I'm measuring the same one thing for all 3 of them. I would compare differences using one-way Anova. Second example, we want to measure fasting blood glucose between a diabetic paleo diet group, between a diabetic non-paleo diet group, and the third group is a non-diabetic group. That's 3 different groups, and I'm measuring the same variable, fasting blood glucose, but in all 3 of them. So I would compare differences with a one-way Anova. Last example, I can measure quadriceps femoris muscle activity between 3 groups. 1 a healthy group, 2 if you're counting right, an MCL injured group, and 3 an ACL injured group. I've got 3 different groups, and I'm measuring the same variable for all 3 of these. Okay, so again, compare means with a one-way Anova. Okay? And big key, you have to have 1 continuous dependent variable. Now, just like in the case of an independent t-test, you're going to have to use an f-test. Now, the difference is when you do an independent t-test, you actually have to physically decide whether or not you're using unequal variances or equal variances. So you actually have to separately and physically run an f-test prior to that. The one-way Anova already does it. So it's automatically done to test for equal or unequal variances. So the p-value that comes out of the Anova, that is just the p-value you use. So actually in some ways, I think one-way Anovas are actually easier to run than independent t-tests, because in the latter you actually have to previously run an f-test. So let's conclude this theoretical part with, generally speaking, you must have 3 or more groups and measuring the same variable across all 3 or more of them. Okay? So now that we've covered that, let's actually go and run one of these in Excel, and I'll show you how to calculate the Anova. I will preface this video by saying 2 things. Number 1, I use the Mac version of Excel, and so if you use the Windows version, it's going to differ ever so slightly, but it's basically going to be the same for all intents and purposes. And number 2, if you have not already downloaded the Data Analysis Tool Pack for Microsoft Excel, make sure you do that, or go and watch the video where I explain very briefly how to download it. It's very simple. I'll put the link to that video in the description of this video. Okay? All right, so once you have the Data Analysis Tool Pack, you can run a One-Way Anova. Notice I have my 3 groups right here in columns. Also notice they have different numbers of data points. Remember, with an ANOVA, it's very similar to the independent t-test, in which each group or column does not have to have the same number of data points, which is different than the paired t-test. All right, so when I want to run my ANOVA, I'm going to go to Data, and once you've installed the data pack, the tool pack, it should appear somewhere over on the right side once you switch to Data. So I'm going to click on Data Analysis, and depending on what you did last, you may have to scroll up. ANOVA, the One-Way Anova is the first one on here, so I'm going to click OK. Now, erase this. So this is my input range. What I'm literally going to do is highlight from here down to here, just making sure that this box of dotted lines encompasses every data point. So for example, I would not want to do this because then I have this 4 excluded here at the bottom. I want to make sure that every point is encompassed. All right, so every